If you're watching this video, this is for number 1 for the calculations practice, Q system equals negative Q surroundings. We have a metal and we are putting it in water. So this is number 1. We have a metal and we're going to put it in some water. Okay, we're going to do QMC delta T, QMC delta T. We're going to start by labeling. For me, it's always easiest to do our grams. So our mass of the metal is 90.2 grams, and our mass of the water is 230 grams. Okay. We know C of water weighs 4.18 joules per gram degree Celsius, so I'm just filling that in now. Okay. I always like to do a T1 and T2 as well, just so I don't accidentally mix them up. Okay. So the first thing, it was heated to 80 degrees Celsius, this metal. So it's starting at 80.0 degrees Celsius, and then we put it at water. The water started at 22 degrees Celsius. The metal and water were allowed to come to an equilibrium temperature, so they both ended up at 62 degrees Celsius. Okay, I'm going to go ahead and find my delta T since I can do that. 62 minus 22, of course, is just 40 degrees Celsius. And for the other one, I do 62 minus 80. Gives me negative 18 degrees Celsius. That's all of the information. I'm going to do letter A first. Of course, we don't have this, we don't have this, and we don't have this. Letter A is asking me to find, assuming no heat was lost to the environment, how much heat did the metal release? So we are trying to find this. Okay. Well, in order to find this, we need to find how much the water was absorbing, because if I know how much the water absorbed, I know how much the metal released, okay, because of the law of conservation of energy. So what we're going to do first is we're going to solve for the Q of water, and we can just do MC delta T for that. When I plug those numbers in, I'm literally just looking at water's information right now. 230 grams, 4.18 joules per gram degree Celsius, and for delta T, 40 degrees Celsius. Cross out units that match. When I type this in, this is 230 times 4.18 times 40. And this is going to give me 38456. And my unit left over is joules. So this is 38,456 joules. So if the water absorbs that energy, that means the metal released that energy. So we're going to take that same number and make it negative. Okay? So since water absorbed 38456 J of energy, according to the law of conservation of mass, the metal released 38,456 J of energy. That is letter A. Okay, so now for letter B. Letter B is now asking me to find the heat, the specific heat of the metal. It's asking for this now, our C. All right, so I'm just going to take my metal information. I have Q now. We know it's negative because it's releasing energy. I'm going to copy that big number down. My mass of this was 90.2 grams. I'm just repeating some work here. This I don't know, but I know it's going to be in joules per gram degree Celsius. And my delta T, which I already found out, was 18 degrees Celsius. I'm going to do Q equals MC delta T for the metal now. Okay. The M in this case is 90.2 grams. Our C, oh, I don't know. And you know what? I want to rearrange this formula to get C by itself first instead of plugging in. So I'm going to divide both sides in order to get C by itself by M delta T. It just means I'll make less mistakes when plugging this into my calculator, or there's less opportunity to do that. So this is my final response when I've rearranged the formula. I'm going to go ahead and plug in those numbers. My mass is 90.2 grams, and my degrees Celsius is negative 18 degrees Celsius. You'll notice none of my units cancel out, but that's okay. So I get negative 38456 divided by 90.2, and then divided by negative 18. Your answer should come out as positive. This time it's going to be a big number, 23.69, I'm going to round up, joules per gram degree Celsius. Okay?